Now we'll understand the BGP route reflectors. We'll explore the fundamentals and functions of the BGP route reflectors. So we already know that BGP is the border gateway protocol. Now, what is the significance of the route reflector? What does it reflect? We already have configured the BGP, but what is the significance of the route reflectors? Now, a route reflector serves as a specialized BGP router that facilitates the redistribution of BGP routing information within an autonomous system. So what happens in the BGP, that is the BGP, you can say the split horizon rule. Inside an AS, there is a rule that if the routing update is received from one neighbor router, it will not be forwarded to the next neighbor. That is to avoid the routing loop. And also to avoid too many BGP peering or BGP sessions, you can create this route reflector. Because if you are having too many BGP peers, then it will be too many broadcast traffic. And if you're having nodes, like n is the node number, then you can have the n into n minus 1 by 2. That is the relationship to calculate the number of adjacencies you will have. So this approach significantly decreases the number of peer connections needed. That is I'm talking about. Like peer connection means BGP session. BGP session needs to be reduced, streamlining the management of BGP session. So what is the benefits of route reflectors? It reduces the BGP sessions. Route reflectors significantly reduce the number of BGP peer connections required within an autonomous system. Because if you are having too many sessions, then that is definitely having too many connections, like too many TCP connections, by allowing clients to share routes through a single point. So there is a single point, and all the BGP peers, BGP clients are actually disseminating the routes to the single point. This minimizes the overall complexity of BGP sessions. So we are not allowing all the BGP peers to actually share the routing updates with each other. They are sharing it with the central figure, that is the route reflector server. And the route reflector server is the central point, and who is actually forwarding it to the other route reflector clients. It simplifies the configuration by centralizing the route information. Route reflectors simplify the configuration process. And this ease of configuration helps network administrators to manage routing policies more effectively. Otherwise, there is a lot of complex process going on, so you have to configure a lot on the peers, and also there will be a burden of the broadcast traffic. So you have to ease it out with this route reflector concept. It enhances scalability, means more routers or more nodes can be accommodated. Route reflectors enhance the scalability of BGP networks by allowing the addition of new clients. So the scalability is crucial for growing organization and complex network architecture. So as you add more nodes, definitely you should be aware of this broadcast issue, and you should create the route reflector there. So how the route reflectors work, you have to understand. First is route acceptance. Route reflectors receive routing updates from BGP client. So it is a centralized point. Central approach means all the clients will forward the routes to the route reflector. Then route reflection to the clients. So that then the route reflector will forward the updates to the client. After accepting the routes, route reflectors provide the necessary updates to BGP clients. So if I am the client, I will send it to the route reflector server, and server will reflect back to the clients. And also route reflection to non-clients. Like route reflectors can also share routing information with non-client. One is the route reflector client, other is a non-route reflector client, maintaining an efficient flow of data across the network. And also preventing loops. To avoid routing loops, route reflectors implement specific rules and policies and ensures a stable network environment. So these are the features of the BGP route reflector, and you have two choices in internal BGP or IBGP. Either you can have the full mesh connectivity, or you can have the route reflector. Another one is there, that is the BGP federation, but here I'm going to talk about the route reflector only. So now let's go to the JNS console and configure it. So there are three routers, and R1 is a route reflector client, R2 is a route reflector server, R3 is also a client. Now we'll configure the BGP relationship IBGP between R1, R2 and R3 and R2, and then R1 and R3 will be configured as the route reflector client. So let's skip the IP. First, you just view the interfaces. The F0 by 0 is connected to F0 by 0 on the R2 and F1 by 0 to F1 by 0 on R3. Now go to the R1. Here I'm configuring one loopback. IP address is 1001. And now I'm using the default mask for now. And also the interface 0 by 0 using 192.168.0.1 and the default mask. And now let's configure it on the R2, it will be 192.168.0, and on F1 by 0, it will be 192.168.1 network. So on the server, go to interface F0 by 0, give IP address as 192.168.0.2, and interface F1 by 0, shut, and the IP address is 192.168.1.1, and on R3, one ninety one sixty eight 1.2. So these are the IP addresses that we have configured, and now configure the BGP relationship router BGP say 1 and neighbor 192.168.0.2. Remote AS is 1 because it is in the same AS. On router 2, router BGP same AS number 1, neighbor 192.168.0.1, remote AS 1, and also here this is a 192.168.1.2 and the remote AS 1, and the neighbor 192.168.1.2, remote AS 1, and here on R3, router BGP is 1, and give the neighbor statement as 192.168.1.1, remote AS is also 1. So this way you can actually establish the neighbor relationship between all the BGPers, and you can see that it's all up. You can check the BGP route table with show IP BGP, but there is no information. In the R1, let's check like show IP BGP, but we do not have. And on R2, show IP BGP, also I do not have. Research, but if the neighbor relationship is up, and if you give show IP route, then also you do not say anything. But if you give show IP protocols, then definitely you can see that the BGP routing protocol is indeed advertising 0.1 and 1.2. And now create the route reflector. So what you do, you go to the R2 and you just create the route reflector client, and also in this you can say you can create the BGP router ID. So here router BGP1, BGP router or router ID, it should take router ID, or let me see, BGP, and there should be router ID. Yes, that is. So router hyphen ID, say 1.1.1.1 on R2, router BGP1, BGP router hyphen ID 2.2.2.2, and on R3 router BGP1 and BGP router hyphen ID 3.3.3.3. Now let's see that show IP BGP. If you give, it is the neighbor is already up, but we haven't advertised anything. So let me advertise on R1 network. So we have created look back with 1001. So 1.0.0.0 and mask is 5000, and we have created network as 192.168.0.0 and the default subnet mask. On R2 on the BGP, here I'm using the network 192.168.0.0 and mask is 255.255.255.0, and also the network 192.168.1.0, and the mask is also the default. Now go to the R3, and here also I have created a loopback interface I created earlier, I think, but let me check. It's only the F1 by 0, and let me check the interfaces. Show IP interface brief, and no, I haven't get it one, only we have the 192.1.1.2. So let me go to the router BGP1 and advertise network as 192.168.1.0 and mask is the default one. So if you do that, so you have advertised the networks also, and if you see show IP route, you now see the BGP is coming, show IP route BGP, you'll see that 0.0, and if I see show IP BGP, now you see the networks that is advertised 191.0.0 and 1.0, and the next hop is 1.1. And also on R2 show IP BGP, you'll see the networks, and also on the R1. And now let's create the route reflector clients on the R2. So the route reflector clients here, it would be this one and this one. So the neighbor would be the 191.168.0.1 and 191.168.1.2. That would be the route reflector client. So router BGP1 and neighbor, that is a 192.168.0.1, and it is route Reflector client. And it is up and the route reflector client configuration. So it changes the topology base and also the neighbor, that is 192.168 and 1.2 is also another route reflector client. So it is actually reflecting the routes, the updates to its clients. So show IP BGP 1.0 and you have the solution show IP BGP. So you have this 1.0. So what happens previously, you can see previously in show IP BGP in BGP's route table, you didn't have the 1.0 information. You had only 192.168.0 and 192.168.1. But now you have got the 1.0 information about the loopback that has come from the R1. Why? The next hop is 0.1. So what is happening? Like this R1 router is sending the update the 1.0 information reflecting to the R2 and R2 is reflecting to the R3. So this is a via process. So we do not have the full mesh connectivity, but we have avoided the split horizon rule. And this IBGP peer has advertised the update to R2, the IBGP, and R2 has advertised to the third IBGP peer. That is the job of the route reflector. So that is a route reflector that I think I've understood. So I'll see you in the next video.